Hello students, now we will discuss satellites of planet. Satellites, suppose it is a Earth with center O, mass of the Earth is m, and capital R is the radius of the Earth. Suppose an imaginary tower of height h, and from top of the tower let an object of mass small m is thrown horizontally with velocity v1. So it will follow the path according to the path of projectile and fall on the earth at point A. Now, if we increase the velocity to v2, again it will follow the path according to the projectile and fall on the earth at point B, which is far away from A. If we again increase the velocity to v3, the path of the object will be like this, and again it fall on the earth at point C. Now, if we increase the velocity up to VO, which is called orbital velocity of the satellite, it follow a circular path around the earth and never fall on the earth like this. It starts moving in the circular path and will never fall on the earth again. Then it is called become a satellite, and VO is the orbital velocity of the satellite. So satellite is the object revolves around the planet or earth is called a satellite of that planet or earth. It may be naturally or artificial. For example, moon is the natural satellite of the earth, and the velocity VO with which object revolves around the planet or earth is called orbital velocity of the satellite. Let a satellite of mass m at a height h is revolving around the earth with velocity VO. The gravitational force on the satellite due to earth is given by Fg, gravitational force, is equal to capital G, capital M, small m upon R plus H whole square, where capital M is mass of the earth, small m is mass of the satellite, H is the height of the satellite from the surface of earth. Therefore, the distance between earth and planet become R plus H. Put it equation number 1. M is mass of earth, R is radius of the earth. Now the necessary centripetal force for the satellite to keep on revolving around the earth is given by centripetal force is equal to m into VO square upon R plus H, where R plus H become the radius of the circular path of the satellite. Put this question number 2. Now this necessary centripetal force for the satellite to keep on revolving around the earth is provided by gravitational force on the satellite due to earth. That is, centripetal force is equal to Fg. Putting the value of Cf centripetal force and Fg gravitational force from equation 1 and equation 2, we get mVo square upon R plus H is equal to capital G into small m capital M upon R plus H whole square. Small m cancel each other, and also 1 R plus H cancel with each other. Therefore we get VO square is equal to capital G capital M upon R plus H. Taking square root both sides, we get VO square root means square root of V naught square is equal to square root of GM upon R plus H. In the left hand side, square root and square cancel each other. Therefore we get VO is equal to square root of GM upon R plus H. Put this question number 3. VO is equal to square root of GM upon R plus H. This is question number 3. The above question show that the orbital velocity of the satellite is independent of the mass of the satellite. That is, it does not depend upon the mass of the satellite. Now the acceleration due to gravity, small g, on the surface of earth is given by small g is equal to gm upon r square. Implies capital G capital M is equal to small g into capital R square. Putting this value in equation number 3, we get VO is equal to square root of GR square upon R plus H, or is equal to capital R into under root of G upon R plus H. That is, VO is equal to under root of GR square upon R plus H. So square root of R square is R. Therefore, it is equal to R into under root G upon R plus H. Put this question number 4. If satellite is orbiting very close to surface of Earth, that is, H is very much less than R, then R plus H is nearly equal to capital R. Therefore, from question 4, we get VO nearly equal to square root of GR square upon R. That is, VO nearly equal to square root of GR square upon R. Now, capital R and one of the R in the numerator cancel each other. Therefore, we get VO is equal to square root of g into capital R, that is orbital velocity is equal to square root of acceleration due to gravity into radius of the earth. VO is equal to square root of GR. G is acceleration due to gravity at the surface of earth, and capital R is radius of the earth. Put this question number 5. So this is the satellite and the orbital velocity of the satellite. Thank you very much.